Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are just going to continue what we were doing yesterday where we were implementing Printf, just to kind of show how to do it and to remove dependency on the C runtime library so that we can be more portable, more easily portable, etc., etc. So, without further ado, today is day 328. We are going to dive on in. So you will want to use, if you're trying to follow along at home, day 327 source code. That is what I'm using right here. And you can kind of see where we left off yesterday. Basically, we parse everything in the Printf now. We may have some bugs in there, but we definitely implemented sort of a scanner for all of it. But you can kind of see in here that we don't actually obey a lot of the printfs. So right now we kind of, we do %s, but things like %d or %f, we just look at and discard. So we now need to go implement some of those % operators that we don't currently do. %f is the hard one, as I mentioned, so we'll leave that one for the very last. That'll probably have to be after we come back. But the other ones are easier to do, and we should be able to make more headway on those in short order, since there's nothing particularly bizarre about them. All right. So let's see what we've got here. We have a number of functions, essentially, that we want, or I guess to say output types that we want to handle. And some of them are, well, a lot of them are very closely related, right? So, D, I, U, O, X, and P, and C are all basically just integer printout. I guess, well, C is not, I think C is actually prints out the actual character. So C is actually a ASCII printout. So that one's actually much easier. But all the other ones are kind of like integer printout. And then the other remaining ones, the A, G, E, F, and so on, those are the floating point printouts. So we should be able to write one routine, since we don't care about this being particularly fast or anything. We should be able to take, at least in theory, a routine that can print out a U64, like one unsigned integer value that's 64 bits long. We should be able to take that and use that to print out basically all of our non-floating point values, right? Because if we can print out a 64-bit value, well, we could just use that to print out a 32-bit value just by leaving zeros in the upper bit, right? And we could use it to do a 16 one by just, again, padding with zeros. So a 64-bit value could print out a 32-bit value, a 16-bit value, and an 8-bit value just fine. And furthermore, if we want to print out a signed value instead of an unsigned value, well, we can just call the unsigned printout routine and just first check to see if the value is negative. If it is, stick a negative in there, and then call the routine with the negated value, right? So we also shouldn't really have any trouble printing out signed values with the unsigned routine. So really what I think we need to do here is just write that one routine that can print out a U64, and then from there we should be able to leverage all the rest of the information pretty trivially. Now the other thing that we know is we could print the 64-bit value essentially out into a temporary buffer if we wanted to, and then do some reassembly. That's actually probably what we want to do here, because regardless of how we actually print this out, we then have a bunch of stuff we need to do that might involve sort of fancy footwork. Like, for example, if we want to pad something with zeros, but we don't actually know yet how long it is, that might be very difficult. So we might want to print to a temporary buffer first, because we know that a 64-bit value can only print to a certain number of individual values, right? Excuse me. Since we know that a 64-bit value can only take so many characters, it's easy to have a little temp buffer on the stack that we just fill with those values. And then we can go, after we fill it with those values, and figure out, okay, how long was it? And what do we need to do with it to sort of straighten it out? And so on and so forth, right? Okay, so let's go ahead and start this process. And I'm just going to kind of sketch out roughly what I want to do here. So in the case of D or I, what I want to do first is say, like, if the value is less than 0, then I want to negate the value, right? And I want to print out a sign. So I want to do like an outchar to a temp, essentially. And we've got this sort of outchar thing, right? Where did that guy go? Well, I thought we did. Outchar, there he is. So we've got this outchar thing, right? And so I could make one of these little format dest guys out of a temp buffer, essentially, and just print to the temp buffer, and then use, do reassembly, essentially, after the fact, right? So here I could do something like, okay, char, temp or whatever. And I don't know how long that should be yet, but we'll just leave it like that for the moment. And then we can say, like, array count temp and temp, like so. I can then come in here and say, all right, if the value is negative, I can output a negative. I assume outchar. I don't remember how we actually wrote outchar. Yeah, it just takes a single char. I can output the negative if I need to, and then I can negate the value. Now, I might want to do that a little bit differently in a second, and you'll kind of see why as I go through it, because I don't know if there's a clever way to, if there's like a interesting way to do what I'm about to do, but I don't think there is. So I actually probably don't want this to happen quite this way, but we'll see. In other words, what I probably want to do is something a little more like this. Probably want to do this, I'm just guessing, where I do was negative, and if it was negative, I negate it. So after that, I just want to be able to process the value. So I just want to be able to say something like, U64 to ASCII or something like this. And what I want to do here, because remember, I need to be able to print out this in a couple different ways. I don't really remember what all the ways are. We can look at the format list, but at the very least, you know that we want to be able to print out things in both decimal and hexadecimal. Now, decimal is base 10 and uses the digits 0 through 9, right? But hexadecimal is base 16 and uses the digits 0 through 9 as well as A through F. So we essentially have two different character tables that we kind of want to do here. So you can imagine, having like hex chars and decimal chars or something like this, and sort of having like a lookup table where we would have each of the digits that are involved in the process, and trying to make a routine that's generic so that, we can choose which ones we want to use. And maybe, like, because this was a stupid little minor spec thing, because you're supposed to be able to choose uppercase and lowercase, heck, we could support that pretty easily by just having two different tables. We don't even have to really change the code at all if we're already supporting it. So what I'd like to do is do a U64 to ASCII where, I pass it the U64 that I want to do. I pass it, this should not be dest, this should be temp dest. I pass it like, please write into this thing. Here's the value I want, and here's the string of characters that I want you to use. And obviously, I'm going to need to tell it how long that is, because otherwise it wouldn't know. Now, in this case, I would have to do array count -1 because the null terminator is included there. I'm just going to tell it it's 10 because we know that it's 10. It's it's decimal. Obviously, it has to be 10 characters, right? So that's neither here nor there. And so then in theory, what I'm hoping, and we'll see if this pans out, is that I can do basically the same thing here, right? So I can, for printing out U, I could use that. For O, I don't remember if that's octal. Unsigned octal. So for octal, it's, actually still the same characters. There's just less of them, right? So for octal, I could just say we'll only use the first 8 characters, right? And if this magic routine works okay, then, you know, in theory, it'll just work, and that'll be fine. So yeah, so then we can do US64 to ASCII. Yeah, and for hexadecimal, this is lower hex chars because it's the small x, and this would be upper hex chars. Don't ask me why that is 27. Somebody had their finger 1 to the left when they tried to type the value. So, you know, that's what we're talking about, right? And I don't know about the pointer value thing, but I'm pretty sure the pointer value bit is exactly the same as everything else. I'm pretty sure that it's just going to print it out in hexadecimal, I think. So I think it's just that. And I don't know whether it's uppercase or lowercase, to be completely honest with you. So, you know, I'd have to look that up. Looks like it's lowercase. So I guess we'll just use lower hex. So I think, in theory, all we have to do is actually implement this function now, and then we could start having some printout there. So let's take a look at what that would entail. And of course, we've got some problems with how we're going to do the precision formatting and all that sort of stuff. But so in this particular case, what's the name of this guy here? It's a format dest. There we go. So we know we've got a U64, that's our value. We know that we've got another thing, which is basically the base, whatever the number system base is. And then we've kind of got like our array of digits, right? So what I want to do here, and maybe I'll switch to the other window so my head doesn't get in the way. So in U64 to ASCII, what is this complaining about? Format dest to format. Sorry about that. I'm going to pass that address. That address, dough. One more of them down here, too. There's one more of them down here. There we go. Okay. Cannot convert to voice art. That is true. So what I really want you to do is pretend it's a U64. The problem with this is I don't really know what size that should be, so we kind of need this to be a UMM, because if we were compiling in 32-bit, we'd want it to be a 32-bit value. So I kind of want to cast it to that, if that makes sense. All right, so let's go back up here, U64 to ASCII. What I want to do now is I have a value. I want to convert that value into digits, and you know, I need to be able to sort of do that in any arbitrary base, right? Well, that's not really that hard to do, right? Because I could easily peel off the numbers kind of one at a time by just dividing by the base repeatedly, right? You know, if I want to know, this is pretty straightforward, but I'll draw it out anyway, just in case it's unclear. So, you know, if I'm here on day 328, and we're talking about printf. If I have a number like 123, and I want to know what the individual digits are of it, right? Well, I know I can take this value, you know, if this is my value. I know if I take the value modulo whatever my base is, right? And I say in this case my base is base 10. If I take the modulus with the base, I'm going to get the remainder, right? I'm going to get whatever the remainder is when I divide this thing by that value. And you can look at this value and know, well, if I was going to look at what the remainder would be if I divide it by 10, well, it's going to be 3, right? It's going to be that first digit. So I can always tell what the first digit is by just doing the modulo with the base, and that gives me, you know, my first digit. So the question is, well, how do I get the next digit, right? And the answer there is, well, if I need to advance to the next digit, I can just actually divide the number by whatever the base was, right? If I divide 123 by 10, then I'll kill this digit off and move one over, right? So v divided by base like moves one digit down, right? And this is integer division, which means there is no fractional part. It just kills the 3 entirely and slides everything over, right? So really all I have to do is like do my modulus and then divide, right? Do my modulus, divide. And I can peel off the digits one by one. Now, there is one inherent problem with this, and this is why I said, you know, temp buffer has its bonuses as well, obviously. And that is that if you think about what order we're going to get the digits in, we're going to get them from the smallest digit to the largest, right? So if I do this process repeatedly, I'm going to get 3, 2, 1. But that's not the number I wanted to print. The number I wanted to print was 1, 2, 3. And so, you know, for our purposes, to keep things simple, we can still use this procedure. We'll just flip the digits at the end when we actually go to output them, right? So that's why I said the temp buffer is also handy, because it means you don't have to think very hard about the output routine, because you can just do the dumbest possible way of getting the digits, and then you can just flip them after the fact. You know, you could try to be more clever than that, but, you know, like I said, in a case like this where it's only for debugging, it's probably not in your best interest to sit around spending a lot of time thinking about the fastest way to print out integers, although, you know, if you are in the mood for, you know, something sort of like a small constrained exercise to do, it's probably something interesting to think about. Floating point certainly is. So anyway, what we can do here is just say, well, if the value equals 0, then we know we really don't have anything to do, right? Then we know we're just basically doing whatever the 0th digit is, and that's it. There's nothing else to do. But otherwise, we probably want to do a while loop. And I guess, you know, what I could do too is just make this something like this. So we'll get in there, and we'll just say, okay, while the value is not equal to 0, we'll do it, but we want to go through it once, because even if it is 0, we want to print out one digit, right? So, all right. So we're going to do exactly what I said. We're just going to have a thing which says, okay, the digit that we want to print, right, like the digit for this time, is just whatever the digits are. And I suppose I can even just do this directly. Well, let's write it out long form. So we'll say digit index equals value mod base, like so. The digit is equal to whatever one that is. And we'll output it, like so. So you can see there we just do the mod. We look up in the table which one that is. And then we output it. Then we just need to advance to the next digit. So we say, OK. Whatever the value was, it's now going to be divided by the base. Now, obviously, you can't pass a base of 0, but we know we're never going to pass a base of 0, so that's fine. And of course, you could never print out a value in base 0, at least not that I know of. Maybe there's a clever math way to do that, whatever that means. I don't know what it means. So that would essentially be our printout, right? That would give us our characters, but again, it gives us the characters in reverse order. So now the caller does have the responsibility of actually doing something with that makes sense, right? So our temp test here has an array count, a situation set up where, yeah, we kind of need to come through here now at the end and do something with it. So assuming that it was filled, right, we could say, you know, if temp dest at is not equal to temp, then we know we've got something to sort of fill out here. And I guess what we could also say is, you know, if this thing was negative, then we want to include that negative sign, right? We want to put in that negative sign. So into the temp dest, we want to put the negative in if it was in fact negative, right? So now we've got the value with the positive or negative sign in there. and it's ready to go. So then all we have to do is say, well, okay, if we're if we're in a situation where we actually printed something out, we can actually just probably print these out in reverse order. We could just say like, okay, back up 1 and print out whatever you've got. So that just like takes our temp buffer and like puts it out. So yeah, we're gonna have to step through that because that's just a ton of weird code, but you know, there it is. And you can sort of see now we're actually starting to get some of these things printing, and you know, they might even be right. Who knows? We're gonna have to go test it because you know, we don't actually know what these values were supposed to be. For all we know, they're not those values, but they certainly seem reasonable. Like it's conceivable that those could be correct values. And yeah, like I said, now we can print out all kinds of integers that we might conceivably want. And so that's a good thing as well. I don't think there's really anything else to say there. It looks all good. Nobody's crashing or having a problem, so that's all fine. So yeah, so that's that. Okay. Now, like I was saying before, we'll put it to do here. Well, I guess implementing writebacks actually, instead of putting it to do, I might as well just do it. The definition for writeback is we're supposed to take however many characters we've used so far and let it know. So we're supposed to just take whatever they gave us and say, well, okay, whatever the temp dest actually is at, and wherever it started. So it started, you know, here at destinate. So if we just take a look at the difference between where we are now and where we started, that's the value that tab-dest wants back. And of course, we've got to truncate that to an integer because the printf spec doesn't allow you to write back 64-bit values. Even though our printf supports more than 4 GB string sizes, fancy that, we wouldn't be able to actually write any of that back. Because at 2 GB, the int runs out of space. So anyway. We have the pointer value as well. All these things are pretty easy. This one, I guess, with the C value, that's going to want to go into the temp dest as well, like so. Yeah. So all of those go into temp dest, and this is actually supposed to be regular dest, not temp dest. I think that all is what should happen. Now, I guess I don't know for strings. I guess I don't know if strings are supposed to follow. Yeah, I guess they're supposed to follow sort of those other rules, the like width rules and stuff. So this is definitely to do obey precision, etc. Precision perhaps not, but width definitely. Like dot star, or whichever one that is, whether it's precision or width, I don't remember. There is a meaning for those. Precision in a string, I think it actually obeys both. I think precision in a string is how long you treat the string to be. So instead of looking for the null terminator, you cap it to that long, potentially, even if there isn't a null terminator encountered by then. And then width is sort of like how wide it prints out. So we do need to obey both of those, and so that'll be something that we have to do. For the rest of these guys who print out into the temporary destination, we should be able to kind of roll some of that in. So for starters, let's take a look at some of these other things here. So positive sign is blank. What were the other one? Force sign and positive sign is blank. Are those sort of contravening values? Let me see what those actually mean. If no sign is going to be written, a blank space is inserted before the value. Forces to proceed the result with a positive or minus, by default only negative numbers. Okay. So we should be able to obey those actually now in our plus or minus. There's only one person currently, because we're not looking at floats yet. There's only one person currently who does that, right? And so what this does here is it says, well, if it's negative, if we're going to force a sign, then we would output it even if it wasn't negative. So I guess actually that the right place to do that is probably in the else clause. So if we're going to force a sign, put a plus in there if you weren't going to put a negative in there, right? Otherwise, and I guess this goes in here. Otherwise, print the negative. In the force sign case, in the force sign case, I guess, I don't know which one of these takes precedence, but I'm guessing that it looks something like this. It's just a wild guess. But basically saying, okay, you know, if this thing was negative, print the negative. If it wasn't negative and you wanted me to always print a sign, I'll print a plus. If you didn't always want me to print a sign, but you told me that I have to leave a blank when it's positive, then I'll print that. Now, if you specified both force sign and positive sign as blank, I don't know that that's the right precedence. Like, maybe you want it to be blank and not a plus if you specify both of them, but it seems like kind of an error to specify both of them anyway, so I don't really know, like, what's the most, you know, maybe I'll say assert not positive sign is blank. Note, not a problem here, but probably shouldn't happen. Be specified. Something like that. Just so the programmer knows, like, hey, you've got sort of conflicting things in there. Seems reasonable. I don't know what the Printf spec says about whether you can have both of them or not. But it's almost certainly a bug if you had them both, I would think, because you wanted one or the other. Because they can't both be in effect unless I'm missing something. So yeah, so that's all we really need to do there. And we can pull this out into a routine once floating point needs this. To do, make this a common routine once floating point is available. So yeah, the rest of these guys just do what they do. They don't have a sign, so it doesn't matter. And these guys are float, which we don't handle yet. So then we're pretty much just down to the outchar stuff here. And let's take a look at what we have to handle. So we've got pad with zeros, left justify, annotate if not zero, I think is... what is that? I don't even know. Used with O, X, or X specifiers, the value is preceded with O, OX, or OX, respectively, for values different than 0. Okay, so basically that's just saying we're going to put something in there if it's not 0. What a strange thing. I don't even know if we should bother supporting that, but I mean, I guess it's not that hard to. I don't know. So it's O, X, and X. I guess it's these, O, X, and X. And it says that it's going to be like an O, an OX, or an OX in that case. So it's really just like, well, you know, if annotate, if not 0, and value is not equal to 0, then we want to output the thing, right? And in the case of this, I guess it's just O. In the case of this, it's OX. And in the case of this, it's O capital X, I guess. Now the problem is these are going to be in opposite order, so technically I guess it's like that. I don't know. That's just, I guess that's just, well, there you go. I have no idea, but that's what the spec seems to indicate we should do, so we did it. While star value, outchar dest. value plus plus. The most inelegant possible way to do this, but there you go. So anyway, that's, I think, all that has to do with that. And so really we just need pad with zeros and left justify. So I think those are the only ones we actually care about. So we've got width, we've got precision, we've got left justify, and we've got pad with zeros. That's what we need to support. Now, I don't actually know what precision means for integers, so I'm going to look it up. Precision specifies the maximum number of digits to be written. If the value to be written is shorter than this number, the result is padded with leading zeros. The value is not truncated even if the result is longer. A precision of 0 means that no character for the value 0. Now, it seems like, shouldn't it be padded with spaces? I guess not. It's padded with spaces if the width is bigger. Man, okay. So I guess you always get zeros in the case of the precision, but you don't always get zeros in the case of the width. Welcome to it, boys. Yeah. All right. So let's come down here and take a look at what's going to happen. So here's our printout routine. And you can kind of see that this is going to have to be extended because there's two things we don't know, or rather that we can't count on. First of all, we don't know whether or not we want to print out all of these characters because it may be that the precision that's specified is not big enough for all of them. Furthermore, we don't know if the width is big enough for all of them, right? So we may need to sort of like print less of them, if that makes sense. But we also don't know whether or not we may need to print more, right? Because it's possible that somebody has specified a width or a precision that is larger than the actual number that we got, in which case we've got to start adding numbers to it to make that happen. Now, there's a couple things I'm not really sure about. I don't really know where the zeros go. So I guess we will have to do one sort of, I guess we might have to do something a little bit more clever here, where we do like a prefix or something, if that makes sense. And, you know, temp prefix or something like that. Because we may need to insert padding like in between, you know, in between the sign or the like 0 or 0x and the actual value. So I think we may need to do something where we say like, oh yeah, you know, we don't actually insert that because it's got to be sort of taken into account separately. And we'll sort of deal with it later. On the plus side, that does mean we probably don't need to keep it in reverse order because we can just output it in forwards order or something. All right. So there we go. So we've got some temp prefix stuff in there. I gotta just call that just prefix. And so when we get down here and we're going to do our printout, we can also sort of do a for star pre equals prefix star pre plus pre outchar dest pre. Yeah. So in theory, that will do what we need it to do. But we still haven't taken care of the things we actually needed to take care of. Oh. I got to make sure my prefix starts out with something I could print in the case where there isn't one. All right. So, yeah. Now we have to start working on actually obeying those widths. I think that these guys, for example, probably all should have had widths and currently aren't having widths. I'm not really sure, but we can always insert some people who need to have them so that we can make certain that we're supporting them properly as a test. I don't know that there's really a whole lot of other stuff here that's printing out numbers. So yeah, let's go ahead and start to work on this. So here's the stuff that we care about. Less justify and pad with zeros. And then we've sort of got width specified and precision specified. So these are sort of all the things that we need to take into account, right? And I don't actually want to define any of these here. They're already defined up top. I just want to, you know, kind of see what they all are. Like so. Okay, so the first thing that I guess I want to try to do is figure out how to get this thing to be the right size. So I feel like the way to do that is just to say, well, I'm going to have to print out a certain number of things. So like I'm printing these things out like so. So what I could do here is say, well, you know, there's going to be a use width. There's going to be a number of characters that I'm going to print out. And I'm going to set that equal to the width itself. But if I have not specified a width, then I guess I'll just use the precision. Well, I guess not the precision, but the precision plus the prefix. If that makes sense. So yeah, so if I haven't set one, I'll just set it to the precision plus the length, whatever the string length is of the prefix, right? Because I'm going to print out the entire thing if you didn't tell me something else, right? So then I have a use width variable that I could legitimately use. And then we have to deal with the precision situation. And so in that case, I could say the same thing. Let's actually use a variable called use precision here. So I'll say use precision equals the precision. But in the case where you haven't told me a precision, so if you didn't say what the precision was, then I'll just use however long the thing is you actually told me you wanted, right? Or I shouldn't say that. However long the thing actually was that it generated naturally, right? And so you can kind of see this, the approach I'm taking here. I'm trying to boil down a lot of variables into one sort of simplistic way that I can actually do a single printout of the characters, taking into account all these sort of relatively complex dudes. So I'm going to leave left justify for a minute and pad with zeros and see, we'll get to those in a second. I'm going to see whether I can get this working relatively cleanly. I now have a precision value and a width value. And so what I want to know now, right, is what is the difference between the precision and the width, right? Because if the precision is different than the width, or rather, if the precision is less than the width that I can actually use, then I'm going to need to pad it. But if it's not, then I don't, right? And so that's actually relatively important for me to know, and so on. So I'm kind of trying to boil this down into some like easy checks, so as I print along, I can do the right thing. All right. So what I kind of want to do here is I probably want to do a bit of a fake out. Since I already have a way to clip, well, you know, maybe I don't actually want to do that. I'm not sure exactly what I want to do here. It's a tough call. But here's the thing. So when we start to print out, we know we're going to print the prefix always, I think. I assume the prefix takes precedence. So I think what I want to do is I want to start printing, and I want to say, like, print the prefix so long as there is width remaining, right? And so every time we print out a piece of the prefix, I'm going to decrement the amount of width we have left. If we run out of width, I'm going to stop printing the prefix, right? Does that make sense? So that seems, and it just eats away at the width that we have, right? Then what I want to do is now I'm left with only the part that has nothing to do with the width, right? So now I have to print the stuff that has to do with the precision. And what I want to say is, well, however much width I have left, if the precision is bigger than that, then obviously I'm going to need to sort of shorten it, right? So I think at this point I want to say if use precision is greater than use width, then use precision equals the use width, right? So I'm going to get down to just the use precision. And then I can say, well, I've got to have some precision left, and I have to still have something to print. Assuming that I do, then I can just sort of do this, you know, exactly as you would expect. Okay, so I think that properly would handle all those cases, but I'm not actually doing any padding yet. So I think this would handle the case where we were too small, but we haven't handled the case where we're too large, right? So what I need to do here is say, well, okay, in the case where the width, I still have precision left, or I still have width left, I need to do some operations here, right? And so what I can do as well is say, well, I know I'm going to print out, well, I'll just do it the long form way. You know, at the end of this, I know I've got a use width and a use precision, and they might both be greater than 0. So the first thing I want to do is pad for the precision. And then the next thing I want to do is pad for the width, right? Something like this. So as I go for the precision, I'm supposed to pad with zeros, right? And when I pad for the width, I'm supposed to pad with spaces. And those are things that, in theory, could be modified by the pad with zeros or left justified. I'm sorry, the pad with zeros part. So we may have to fuss with that slightly in a second. In fact, I guess we could literally just do this, because this is what that is, right? I think. We would just pad with zeros. But I guess the pad with zeros has to happen at the front, now that I think about it. So I guess I have to check up here and do the pad here, right? So I have to say, like, if use precision is greater than used width, then the use precision is going to get clipped. But on the other hand, if used width is greater than used precision, I need to do the pad actually here. So this is actually this. While the use width is greater than the use precision, I got a pad. I think that's actually correct, right? So that's basically saying, like, okay, we've got to clamp those two down. But then if I have width that's left over, I've got to stick zeros in here to kind of make sure that I, you know, fill everything up to the point where I'm actually going to print it out, right? Furthermore, I think this needs to be done up above because the yeah, it does. Furthermore, I think it needs to be done even higher because, right, it should be part of the prefix thing here, right? I should pad before I put the prefix on, I would assume. So I think I think what I need to do is say, well, as long as the use width is greater than what I'm actually going to want to print at the end of the day, then I need to kind of pad it up front. That seems right to me. Then I do all my printing out of the prefix. So now I should get to the point where I'm ready to go. I then have to clamp the precision in case it was going to be too big. I then use all that up. But at the end of this, I still may have more room. I still may have precision left over that I would need to pad. And so that's going to be the same thing, I think. So I need to have the exact same kind of loop where I just kind of decrement the precision going forwards by padding with zeros. All right. Kind of heinous, but there you go. So I think that actually does mean, though, that left justify probably isn't too hard to implement. I think all we need to do to implement left justify at that point is say, well, okay, we've got a use width specifier here that's going to pad with the zeros on the front end, but we could say, you know, that's only if we're not left justifying. We're right justifying. If we do want to left justify, well, we could just do this at the end after everything else is done, right? The only difference there is we have to make sure we actually track the width everywhere just in case. But that doesn't seem too hard to do. You know, whatever, right? So here we could say if we are left justifying, then we just need to say, while there is still use width, then you pad with whatever the padding is that you're going to use, if that makes sense. And I'm not sure what would happen in the pad with zeros case. I think you have to be padding with blanks in that case, because if you're going to pad with zeros, it doesn't seem like there's any way to ever do that. So I would probably say that left justify I would probably say that left justify pad with zeros, left justify equals false, assert not left justify. Note, not a problem, but no way to do it, I guess. All right, so let's see what we've got. U32 here. Well, I guess there's really no reason to do that. I could just make these all be UMMs. Signed, unsigned mismatch between... Oh, well, I know that that's not fine. Do we have a signed memory value? Yeah, so that's just a lot of ridiculously finicky code. So I'm not particularly expecting any of it to work. We're going to have to step through it all and actually verify that it works at all. And you can kind of see that, like, well, we didn't completely fail. Like, we're now getting columnar output here in a number of cases, so some of our stuff is working. But you can also see that, like, we've got a little bit of a problem here with our percentages. I'm not sure, although were those floating point numbers? So maybe we didn't mess anything obviously up, because I think those are supposed to be floating point numbers. Why we're getting anything? Oh, well, I guess that would just work, yeah. Okay, so I guess You know what? Honestly, I guess we don't necessarily know that we did anything wrong because we don't have any obvious errors yet. I mean, that probably, it's unlikely that we implemented all of that correctly. Like, that just seems not particularly likely, let's be honest. So, you know, I wouldn't hold out hope for that, but that is kind of cool. Like, hey, look, everything just kind of worked. First time out, give ourselves a little pat on the proverbial back. But like I said before, even though that stuff kind of works, we still are left with the problem of being able to print out the floating point values, which we do not have the ability to do at the moment. So that's really the one that's going to be sort of an iffy one. But we're out of time. So, you know, that's pretty much it before vacation, I suppose. And that means that, I guess the intrepid among you, I could just say, you know, homework assignment people, you gotta figure out how to print out a floating point value. Go read that paper and see if you can add it. You could try. Let me see here. Oh, it's there. It was there. Is this it? This is not it. Maybe, was it 2016 or was it 2015? This is the actual one. Okay. So if you are so inclined, you could go read this paper and implement it. I will be away for a while, so you certainly would have time to put it in there. And I seem to recall it not being particularly lengthy in terms of code. You know, I mean, there's that and this, but they give you basically the pseudocode for it. I have not looked at it myself, but you could look at some of these and see. I don't know that they're going to be particularly onerous to implement, even if you don't totally understand them in all of the math behind it. Like I said, I haven't really looked at it myself yet, so I can't tell you how difficult that's going to be. But that is certainly something that you could do for homework. In the meantime, I've still got a couple of minutes left. I just wanted to take a brief look here at string output, if that makes sense, and just to see, as I spill watered down limeade all over myself, which is always a good start, just to see how we're going to actually do that. Now, one thing I should probably do is say, well, this whole thing should probably only execute if we actually want to print out the temp buffer, because the string has to do its own thing. So I think we want to sort of do this, just to make sure that we're only actually doing that stuff in the case where we actually care about it, right? So I think all of these values besides the floating point ones are now sort of doing probably roughly maybe what they need to do. So the only one that we really have a problem with, I think, is the S value. And so that one's going to print out this string. And it seems like in order to obey the precision and the width in this case, wouldn't be particularly difficult. All we really need to do is sort of handle stuff similar to how we handled it below. Unfortunately, we kind of need to duplicate it probably. You know what? No, I guess we really don't. So I guess what we could do here is say, well, let's just set the pointer for this stuff to our string, right? I think I can just do that. So I could say, well, the temp pointer is going to be the string that we got. The temp dest, how does this guy work? Oops. Right, because we just need to read from it. So I could just say the size of the string is going to be the string length of whatever the string is. So just pre-scan it. Yeah, it's slow, but hey, we're just trying to make a compact version of this thing, and we don't care how fast it runs for the most part. It's only debug code. So I could say the temp pointer is the string, the temp dest size, the string length temp dest at is the string there, and then I think that just works. The only thing that I think we want to do is make sure we never read off the end of the string in case they were trying to use the precision specifier to prevent us from reading off the end of a string that doesn't have a null terminator on it. So what I might say is, well, if use precision is on, I should say precision specified. If precision specified is on, then we need to only look as many as there are actual precision things, right? So I would want to do something like temp dest size equals 0, you know, char star at or scan equals string star scan plus scan plus temp dest size. So we'll like add, you know, we'll increment as we go to kind of find the location there. This is going to be kind of heinous if we actually want to do this though, because we would have to reverse the order. So I guess that's a little easier said than done, but oh well. All right, so if we come through here and we say like, okay, what's the precision that's specified? Then we have to sort of scan through to see whether or not we've hit it. And what I'll do here is just say, well, as long as the temp dest size is less than the precision, then we keep incrementing, right? So that way we'll never look past the end of the string, which, because I know that you're not supposed to do that, because I use that in Printf all the time to print out strings that don't have a null terminator at the end. So we don't want to go hunting for a null terminator in the case where we know that we've hit beyond the length of the string that we could possibly print out, right? Now that would just work, sort of. Except for the fact that now, because we print out things in reverse order, all our strings will be backwards. So like, for example, oh, that's not what I would have expected. What's going on there? Temp dest size equals string length string. Oh, I of course have to move it past there. Yeah, so you can kind of see the prop. It doesn't look good. Sorry to go over time, but I just kind of wanted to put in this guy. It's like the last little thing. Precision specified, temp dest size equals 0, temp dest size equals string length of the string. The at is going to be pointing sort of off the end of it there, right? Because that should be right at the end. So it should be, I mean, it should be the string pointer plus however far we said we were going to go, yeah? That seems right to me. Am I missing something there? was missing something there. That needs to get advanced every time we read one of those characters. So that was a mistake. All right, back to our story. So yeah, like I was saying, the problem here is that anytime we print out a string, we're going to print it out backwards because that's the way we're reading from our temp test, right? So I don't know how we want to solve that problem. You can kind of see here we've got the loop that actually reads from it is this one right here. So what we could do if we wanted to is just have two loops here, whether or not we want to reverse. So we could do something like if reverse we do it one way, otherwise we do it a different way, right? In either case, they're going to be essentially the same, but in one case we'd go from the beginning forwards, in the other place we'd go backwards, right? So in this case we'd do that. So yeah, ladies and gentlemen, Printf, pretty disgusting. Anyway, we'd assume that we'd reverse because all of our numbers print out in reverse order, and that's fine, but when we get to the string, we don't want to reverse, same with outchar. So in here we'd say reverse is false. Of course, that's only one character's worth, so it doesn't matter whether we reverse it or not, but point being, either of those two would not be reversible. So now I think we'd actually be obeying that even in the case of strings, so that now you could clip the strings and left justify your strings or do whatever else you want. I don't actually know. Let's find out if that works. I mean, who knows? Let me go over to the debug thing and see where we do like our CY printout, right? Let's get a different one here. What is this? Draw profile bars. It's not really what I want. Draw profile in. I think draw top clocks list. That's the guy. So here's our top clocks list, and you can see it printing out the S here. I don't actually know, like, let's just play with this and see what happens. So left justify is what again? I don't even remember. Crazy printf. Left justify is negative. That's what that is. So let's just throw that in there and see what it does. Because who knows? I have no idea. That in no way left justify. Oh, wait. But strings by default left justify. Right. So it would be numbers that would be different if we left justified them. So it'd be like that. Would left justify the number if we implemented it properly, which we probably didn't, let's be honest. There we go. Well, hey, all right. That was surprising. I wasn't expecting it to work, and it worked. That's good, I guess. So for a string, if I actually set the width, then I should be able to see left justifying or not, I guess. So let's say I set it here to like 40 or something, because who knows. Then I should see all these guys flip over to the right side, no? Yeah. So that all worked fine. I am kind of shocked that this is all working. That's a bit odd, but whatever. All right, so that all worked. Let's try it with that, but with a precision specifier now. Wow. All right, well, good stream to go out on, I guess. Because all that stuff just sort of worked. How about pad with zeros? And left justify doesn't do anything with that, right? So we should assert. Yeah, which is good. So, all right. There you go. Let's go to the Q&A. Any questions? Let's see. I posted my question twice on pre-stream, but both times it wasn't addressed. I experienced a bit of lag back then. So I checked on archive what's up and it wasn't there. Am I doing something wrong? I don't remember seeing a question by you in today's pre-stream. What was the question? Sometimes I don't address questions if I don't want to, obviously, but I don't recall seeing a question by you that I didn't want to address. A few people in the Twitch chat are asking about what level of math do you think is required to be an effective programmer? Well, I think that depends a lot on what kind of programming you want to do, right? Because, you know, programming, there's a lot of different things that happen in programming, right? So, you know, if I'm working primarily on like high concurrency data movement stuff, then the sort of slice of math that I have to know is probably not that huge. Possibly not really very much at all, depending on whether I'm working on theoretical aspects of it or not, you know? However, if I'm a game engine programmer, the math is just dumped on you everywhere, right? There's math. There's so much math involved in game engine programming, you can almost not know too much. I've never learned a piece of math and not been like, oh, I could probably apply that to something I do game engine programming wise, right? So, you know, I think that's the thing that you really have to ask yourself is, what kind of programming do I actually want to do? And how good at it do I want to be? And the combination of those two answers is going to tell you how much math you need to know. Certainly, if you're going to be a game engine programmer, you know a lot of math. That's just the case. But if you're not going to be a game engine programmer, if you're going to be some other kind of programmer, then the amount of math you need to know could vary pretty dramatically. And so you kind of need to know the domain and the necessities of the domain before you can really, you know, answer that. Casey, I understand that you're replacing all the string header functions. Are you not worried about optimization for these new functions you plan to write? Correct. I am not worried about optimizing these functions because we never actually do anything with strings in Handmade Hero, actually, that's user-facing. It's pretty much all debug stuff. And the amount of string printing and stuff we do is so limited that it just doesn't matter, right? It's not like the rasterizer or stuff where we were kind of, it's like a really heavy, very important critical path item that we wanted to, like, you know, try to do some work on. I'm just trying to learn how to code. I'm following Strustrip's book, and he insists on teaching using math. All the good beginner books tend to assume math knowledge. Yeah, I don't know too much about that, to be honest, because I don't know what are the good beginner books these days. I mean, I would sort of state the obvious cavalier snubbing and say that I would never learn programming from Strustrip because he's not a good programmer, right? Like, you should try to learn programming from people who program well. So there's that. But that said, yeah, I don't know that much about what are good beginner materials right now. I've kind of said in the past that I would like to do a beginner stream at some point that, like, kind of teaches introductory programming, but I haven't done such a thing. And obviously the programming we do on Handmade Hero is designed to be introductory for people learning game programming, but not introductory for people learning programming. I kind of assume that you already know what a pointer is. For example, you know, in episode 1, So for people who don't know what a pointer is, that's really not going to help, right? If that makes sense. So I guess that's what I would say. I apologize for not knowing what the answer to that, but you have to remember I learned to program 30 years ago. So, the introductory materials that are available today are nothing like the introductory materials that were around when I was learning. And so I don't actually have any familiarity with them. I'm also not really in a position to really judge them. I mean, what you'd want is some people who learned to program, who have tried some of the various ones and maybe have more of an opinion of, what worked for them and what was easy to get into and what gave some good grounding on the concepts and that sort of stuff. So, yeah, sorry I don't have a better answer than that. But I do kind of see it as something that should be addressed in the future. I'm not necessarily convinced that there even are good beginner materials right now, at least not ones for people who want to be serious, programmers who understand CPUs and computer architecture and that sort of stuff, as opposed to people who want to be I don't know, I just program in PHP or something, right? There may be very good materials for that, but that's not what we do in games, and so it's it's not really relevant to the kinds of programmers that I am trying to sort of reach with Handmade Hero, for example. So I do think better beginner materials probably are necessary, and they may not really exist at the time, and I apologize for that, but one step at a time. So let's see here. Neris909, I guess I know what the problem is. From the port where you say, I posted my question twice on pre-stream, both time it wasn't addressed, down to the part where you say, and again, just let me know if you see it. Those are the only two things that came across in the Twitch chat. So it's not, whatever you're posting is not coming across. I don't know why, but it is not actually showing up. So that is probably a very good answer as to why you were having trouble getting me to see the question. Yeah, there in the Twitch chat, as opposed to maybe the IRC chat, there's an IRC, there's a Handmade Hero IRC you can use on Handmade Network. On the Twitch chat, they may have all kinds of weird stuff that bans long messages or messages that include links to things that they don't like or who knows what. InsoBot is the only moderator of the channel that I know of, and it usually says if it does anything. So it's probably something native to Twitch. I would encourage you to maybe break it up into multiple pieces. So maybe cut and paste just one sentence at a time and see if you can paste it in that way. If not, then there's another easy solution too, which is you could just make a paste bin somewhere, like a GIST or something, and then just post the link to it, and then I could just go to the link and view it. Okay, so I saw one now. It says, hey, in 1 year I'm graduating and it will be time to find a job. All I always wanted was to work in the game industry, but I have no work experience or projects that I am proud of to show as my portfolio. I guess you were leading programmer in your projects and you were responsible for making decisions who to hire. And then I'm guessing there's going to be more to the question in a second, although I can sort of assume that it's going to be asking about that process of how candidates are screened and so on. So I've kind of answered this a couple times in the past, but it's been a long time since I've answered it, so I'll kind of just quickly rehash that territory, assuming that I know what you're going to answer. I mean, what you're going to ask. So 3 things. First one is actually I have never been involved in any entry-level hires. That's just never something that I ever was in a position to do. I've been involved in pro level hires, like hires for engine team people with experience and that sort of stuff. So I actually don't have any experience on the sort of hiring manager side for a person fresh out of school. Like I have literally no experience that. I've never been involved in that. I have no idea how that goes. So I'll say that. The rest of the questions came in. How you see people like me in the decision, should I take whichever offers a programmer I could find, which might not even be connected with games, or maybe try to make the best game I can do in a year and save enough money and join an internship without salary? I didn't see any studio with paid one in my region. What's your opinion? Yeah, so that's the first thing I'll say. Two, when I got into the game industry, it was very different than it is now. So I also, unfortunately, don't have much experience to share about how to get your first job, because my experience was at a time when the industry was completely different than what it was now. Completely different. And how I got into the industry pretty much has no bearing on how anyone else could get into the industry, especially not today. So unfortunately, that's the case. And the third thing I will say is I did pose this question to Mike Acton, who is the head, the tech director of Insomniac, people who do like Ratchet and Clank, and Sunset Overdrive, and they're doing the new Spider-Man game, and so on. So big AAA company, but very serious about little programming. And his answer is archived in the Handmade Con 2015 video series. So if you want to go check that out, no, that's somebody's repost of it. Where is it? Should be a playlist. I need to put these up in a way that's easier to find. Oh, well, that's the one I was looking for anyway. So here's the Mike Acton interview, and I don't remember exactly where he talks about this. But in this interview, I asked him this question because I always get this question on stream, and he is someone who is involved in hiring sort of a broader range of people, whereas I never really was. I was only involved in hiring like very, very high-end individual contributor kinds of people. So you could check out that video for some of his answers, but I don't think he specifically addresses sort of the latter part of your question, which is what should you do in terms of whether you should make a project or try to take a job or those sorts of things. And I would say that that's kind of depends on how good of a programmer you are at this point, probably. If you can do something impressive that you can post on the web, it doesn't really have to be a game. And it depends on what kind of programming you're talking about. If you're talking about, just Unity scripting or something, then I have no idea, right? That's not the kind of programming I do. It's not the kind of programming that I have any experience with, whatever. But if you're talking about game engine programming, then, you don't have to make a game. You just have to do something that you can post online that demonstrates that you have core technical skills, like the kinds of things we do on Handmade Hero, just showing that you can do that. So, for example, you could do something where you, take something like, implement your own software rasterizer or interactive ray tracer or something like this. Take a small project and just do a good job on it, and so that you can point to it and say, here's what I did, right? And that is pretty valuable, right? It shows people that you can do something, and that you can do something relatively complicated. Now, the question is, can you do that, right? Because maybe you're not at a point yet where you can do that, and that's okay, right? Like a couple of years into programming, depending on how long you've been doing it, you're not going to just be like Mr. knows how to do everything or whatever. And so at that point, you kind of have this situation where, yeah, if you're not a good enough programmer yet to really stand out, do take whatever job you can get if there's anything you can learn from it, right? If you can go work at a company, there's probably a good programmer there, or at least a programmer who's going to be at least better than you. And that's someone you could learn from, and then you can get good enough to start standing out a little bit more and getting a job somewhere where maybe you want to get a job more. So yeah, you do need to kind of assess like where you are and how realistic it is that you're going to be someone good enough to want to like stand out in a pack and get a particular job, or whether you're someone who's like, you're not there yet. And there's nothing wrong with that, right? I certainly can say from experience that I've made really pretty dramatic increases in ability in various aspects of programming based on having worked with other people and sort of having that experience of seeing how other people program and stuff like that. It's one of the reasons I'm doing Handmade Heroes, so people just have a, if they don't have the ability to go work at a game company right now, they can watch how I program and you just get a programmer, right? And similarly, the same is true for a lot of other people who are streaming now, right? Like you can go watch Sean Barrett stream and you can watch John Blow stream, and that's a great place to kind of do that, right? Watch how they code and learn from that. That's really good. And if you can get a job doing that every day somewhere, I mean, yeah, you're probably not going to be fortunate enough to land a job where you're programming with someone as good as John or Sean, but you can still work with a more experienced programmer and maybe learn some things, hopefully in the process. Now, if you can't, right, like maybe the only job options you have are places where the programmers are just awful, right? It's like you can only get a job at a place that's like it's staffed entirely by Bjarne Strostrup and Scott Myers or something, right? Like those are the only two programmers there. So the only thing you're going to learn is how to type a bunch of text that doesn't do anything into a computer and have it run slowly, right? That's the only thing you're ever going to learn. But hey, there's a lot of const in it everywhere, so that's good. Then yeah, I don't know what to do. I really don't, right? If you don't have the opportunity of going to work with anyone who you can learn from, then maybe it is best to just try to go like, hey, okay, try to watch streams online of people who are good programmers, like the aforementioned. Try to get to the point where you can do something where you might be able to get the attention of somebody who is, any company that might have some people at it that you could learn from, and then just keep trying to get a job at one of those. And I guess I don't know that there's really anything else you can really do at that point. It's tough. It's definitely a tough industry to break into. So the more you can do to stand out in it, the better, certainly. And that is one of the reasons why I would say try to be diligent if you can and make something interesting. It doesn't have to be big. It just has to show that you get this stuff, right? It's not uncommon to get people who are like interviewing for entry-level jobs who don't know like what the values in a matrix mean. Like they couldn't, maybe couldn't even tell me what's the first column of a transform matrix? Like explain it. You know what I mean? What does it mean? What's the first row of a transform matrix mean? Stuff like that. It's not uncommon to get people who come out of college and don't know these things. So on the one hand, it's also kind of nice in the sense that there's just not a lot of good people out there at the end of the day. A lot of people are just really bad at programming. A lot of programmers, most programmers are bad. And most people don't know a lot about a lot of the things you might want to know for game programming. So one of the nice things is the bar is not actually that high. The problem is there is a bar, right? Because there's plenty of chat. There's plenty of people who just like, I know how to program Java from college and I'm applying. And so if you're just one of those people and you don't have anything specific to stand out, it is difficult, right? It's kind of a crapshoot at that point. And, I don't know what you can do. But like I said, I think the good news is, you don't have to make some amazing, huge thing to impress somebody. You just have to pick something and show that you can focus on it, that you're curious about it, you took it apart, you understood it, and you did something cool there. That's enough, right? I'll give you a simple example, and don't, take this for too much, I guess, because, like I said, I'm not involved in entry-level hiring, so my opinion is not that meaningful here. It would be better if there was, someone from Electronic Arts or something who had more experience with that, who could say, here's how we hire. But how do I get? I think I retweeted it. Okay, so I'm just going to use this as an example, just a simple example. So here is a tweet that somebody tweeted at me. They said, moving towards an interactive path tracer, I find I'm using Handmade Heroes 2D rendering code time and time again. And they just have a screenshot. Here's the code, some code on the screen, and they did a nice little sphere ray tracer. I can see that they've got, glossy reflections. They've got, depth of field, it looks like. So they even had some kind of rudimentary lens model perhaps happening there. And so on. And then they've got, some code I can see they got to do here for linear color space. So they're thinking about the color space, right? That alone tells me a bunch about this person, right? I can look at some of their code right now. I can see that they've got something running. I can see that they kind of understand some of these things. I'm like, this person would already be more on my radar as an entry-level hiring manager than some random resume that came across, right? It's like, so that's, you should have something like that probably. It certainly can't hurt. And, think about it. Doing a programming stream might also be a good idea. Like when you're good enough to start programming streaming, maybe, have a stream or two I can look at and say, is this person, let me see how their code looks and how they go about their coding process. Maybe that gives you something to, I don't know. But just, throwing that out there, it's like, if you can show that you do stuff and that it's stuff that's non-trivial, that's really good. And that helps kind of put you a little bit more on the radar of people who are going to be doing hiring than, somebody who just sends in a piece of paper that says, I'm looking for a job. And the response is, thank you for the in-depth explanation. I have one more question. Since you're going on a break, can you trash out OOP just a bit so we don't get confused in the time you're not there and stick to beloved compression-oriented programming? No. I think I've already trashed OOP enough. Everybody knows that I hate it. And, either they think it's good or they think it's bad. And at the end of the day, I don't care how other people program, as long as I don't have to work with them, right? As long as I don't have to work with a person who goes OOP nuts, I don't care, right? They can go OOP up all their stuff. Unfortunately, it does mean sometimes like I have to use software written by OOP stuff that's just awful. But OOP alone doesn't make software bad. It's you can make really bad software just no matter what methodologies you follow, you can make lousy software, right? There's so many decisions that are more than just what your fundamental methodology is. It's but one ingredient in making a good piece of software is to have a good methodology. So it's not like you just avoid OOP and you make good software. Like, no. There's that. But anyway, I'm going to go ahead and wrap it up here because it is time. It is over time to wrap it up, obviously. So I'm going to call it for a while, actually. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you wanted to follow along the series at home, you can always pre-order the game on handmadehero.org. It comes with a source code, so you can play around with it yourself. We also have a forum site. If you want to ask questions, you can go there. We got a Patreon page if you want to support the video series, a schedule bot that tweets the schedule at you if you would like to know when we're going to be live, and an episode guide that you can use to catch up on past episodes. I am going to be away for a little while, so it's going to be a few weeks before I return to Handmade Hero. I hope that you will find some good programming to occupy you in the meantime. I'm sure that some of the usual suspects will be doing streams. Probably both Seans, I'm guessing. I'm assuming Sean Barrett and Sean McGrath will both be streaming. I don't know who else will be streaming. Maybe John Blow will do another language stream, but I'm sure there'll be some streams to keep you busy in the meantime. There's always the past episodes. If there's some that you've missed, you can go do that. Or pick a little bit of programming to do on your own. That is always the best way to practice anyway. Maybe you can go implement the floating point printout for our Printf routine, or do anything else you might like to do in advance of us actually doing it on Handmade Hero. You know the to-do list as well as I do. You could go pick something and beat me to it while I'm on break. So that's about it. I'll be back here in a few weeks. Keep an eye on the tweet bot. If you want to know when we are going to be back, I will tweet a few times when the series is returning, so you won't miss it. Until then, everyone have a good time programming for the next few weeks, and I will see you on the internets. Yeah, you can always tweet at me on Twitter or anything else in the meantime. So that's it. Have a good break, everyone, and I'll see you when I return.